Hi, hello, and welcome to another session on data communications and networks. In today's session, we'll see the fourth and fifth type of physical topologies, that is the ring and the hybrid topology. So, in the previous sessions, we have seen the star topology, the mesh topology, bus topology. Okay. So if you see the previous topologies, that is the mesh topology and the star topology. So both of these two were using point-to-point links or point-to-point connections. So even the star also uses a point-to-point connection. But if we see the bus topology, that was using a multi-point connection. Okay, so point-to-point connection was used in the mesh and star topologies, and in the bus topology multi-point connections were used. We have also seen how to calculate the number of physical links in the mesh layer in the mesh topology. So we use this formula n into n minus 1. So this is the formula used to calculate the number of physical links in the mesh topology. So if n is the number of devices or number of nodes, we use this formula n into n minus 1. So this is the formula we use if we use unidirectional links. So that is, if the links are unidirectional, we use this formula, but if the links are bidirectional, we use the formula n into n minus 1 by 2. So this is how we calculate the number of physical links in the mesh topology. We have also seen the star topology and also the bus topology. So in today's session, we'll see the next topology, that is the ring topology. So in this ring topology, every device has a dedicated point-to-point connection with only the two devices which are present on both sides of it. Suppose this is a device D1, so it will have a dedicated point-to-point connection. Suppose you have a device D0 this side and the device D2 on this side. So there is a point-to-point connection between both the devices which are present on either side of this device D1. So this is the physical structure in ring topology. So we'll see the actual physical structure of ring topology. So here we'll use 6 devices or 6 stations. We'll call them as stations. Station 1, 2, this is station 3, this is 4, station 5 and the station 6. So these are the same nodes or the devices. So here we use a repeater for every station. So these small blocks, we call them as the repeaters. So repeaters are connected to each and every station. So from the repeaters, we have this dedicated point-to-point links. So this is how a ring topology is connected. Okay. So from here, the repeater is connected to station 1. So this is connected to this repeater is connected to station 2 and this is connected to station 3 and so on. So this is the physical structure in a ring topology. So in a ring topology, every station or every device or every node is connected to the two nodes which are present on both sides of it. So station 1 is connected to 2 and 6, 2 is connected to 1 and 3, 3 is connected to 2 and 4, 4 is connected to 3 and 5, 5 is connected to 4 and 6, and finally station 6 is connected to station 1 and station 5. So this is the physical structure of a ring topology. So if you see the diagram, we have a dedicated link between any two devices. So between 1 and 2 there is a point-to-point link, between 2 and 3 there is a point-to-point link, 3 and 4, 4 and 5, 5 and 6, 6 and 1. So these are all dedicated point-to-point connections. Okay. Next, we'll see some of the features. We have some repeaters here. So this repeater, this is a device which amplifies or regenerates. So repeaters are used to amplify or regenerate the incoming signal. So this is done to expand the coverage area, because we have seen in the bus topology, whenever the signal is passing through longer distances, the signal gets attenuated. So here also, to remove that problem, we are using repeaters. Repeaters are used to amplify or regenerate the signal. So you can see every device has a repeater. Every station or every device or every node has a repeater. So when any device receives a signal which is intended for the other device, so this suppose you want to transmit a message from station 1 to station 2. So this receiver of station 2 will receive the signal from, repeater of station 2 will receive the signal from the repeater of station 1. So if the signal is attenuated or degraded, then this repeater amplifies the signal, and that signal is given to station 2. So this is how the message passes between various stations or devices. We'll see some of the advantages of this ring topology. So advantages of ring topology. So the first advantage is it is very easy to install. So installation is easy. Then we can see every device is linked. So every device is connected to only its immediate neighbors on both the sides of it. So every device is linked to only its immediate neighbors. So another advantage is, even if you want to add or delete a device in between, we can just disturb only two connections. So if you want to add a device or delete a device, then only two connections can be changed. So these are the advantages of the ring topology. Next we'll see what are the disadvantages. You see the disadvantages. All the communication links in this ring topology is unidirectional, because device 1 can transfer only to device 2, 2 can transfer to 3, and so on. So because of this, there may be some problems. So the traffic is unidirectional. So this is a disadvantage, because if device 1 wants to transmit to device 6, so if you see the diagram, in the diagram from D1 it has to go to D2, from D2 to D3, D3 to D4, D4 to D5, then finally the message reaches D6 because of these unidirectional links. So that is a disadvantage. Another disadvantage is if there is a break in the ring. If there is a break in the ring, what happens? The entire network is disabled. So entire network is disabled. This is the biggest disadvantage. So these are some of the disadvantages in this ring topology. So applications of this ring topology are, this was used in the IBM. in the LAN connections. IBM used this in the LAN connections, but nowadays we don't use this ring topology. So it is not used nowadays. So this is all about the ring topology. We'll see the last topology, that is the hybrid topology. So by the name we can understand that it is a combination of two topologies. So here we use the star topology. So hybrid topology is a combination of star topology plus the bus topology. So we'll see the physical structure of this hybrid topology. So here also we can use stations or devices. We'll use devices here. So this is D1, D2 and D3. Three devices are here. So these three devices are connected through repeaters. So here also every device has its own repeater. Then we have device 4, D5 and D6. So these three also have their own repeaters. Next we have D7 with its own repeater, D8 with its repeater and D9 again with its repeater. So these are the repeaters. So these are connected to each other. Then this is the end of the link. Now on this side, these are connected to a central hub. So this is a hub. From here there is a connection to this point, from here to here and from here till here. So this is the physical topology of physical structure of a hybrid topology. So here we have star connection plus the bus connection. So if you can see this, the central controller or the hub is connected to this individual links in the form of a star connection. So this is a star connection from central controller to this first line, second line and third line. And we have a bus topology from here. If you see the connections from here till here, this is in the form of a bus. So the hybrid topology is a combination of star topology plus the bus topology. So coming to the advantage and disadvantage of this hybrid topology, they are the same as the star and the bus, combination of both of these two. So these are the 5 topologies which we have seen till now. First one mesh, star, bus, ring and the last one is the hybrid topology. So these are all the 5 physical topologies in data communications. So that's all in this session. I hope I am clear. Thank you.